Okay, here we are. This is the second example for beam analysis, and I've got a uniform load here. So pause the video a second and copy this down. We've got 18 feet, and we've got a uniform load of 1,090 pounds per foot. Okay, so that was step one, draw the problem given. Step two, redraw the beam and replace with the supports. I've done that right here. I don't have any other horizontal forces, so I'm going to not put in my AY because I don't need it. I'm going to give you a second to pause it and copy this down. Okay, now I replaced the supports, but I also want to replace the uniform load with a point load. So I'm going to show you how to do it. I drew it here, but we need to know how big that point load is. Well, it's really easy. If the uniform load is 1,090 pounds per foot, and the whole thing is 18 foot, we just multiply those together to get a total load of 19,620 pounds. And it's going to be, we're going to replace it at the center of this load. So that's why I've replaced it here 9 foot on each side. So this load right here is 19,620 pounds. Okay, next part. Find our reaction forces. We did this in part one, so I'm going to just go ahead and pause it and put these down. Okay, so I've gone ahead and calculated the sum of the forces and the sum of the moments just like we did on video one. Pause the video and copy this down. And if you don't remember how to do it, look back at the video part two that I did on the point load. So I now have my reaction forces, and I'm going to go ahead and write those reaction forces on my sketches. What I found is that they're equal on both sides. That should make sense to you. If I have a load directly in the middle, then half of that load goes to one side and half goes to the other. Should make sense. So now I've sketched out my axis for my shear and my moment, and I've drawn in my dashed lines where my load is and where my support is. So you should remember from last time that we start our shear diagram by putting this reaction load on this side here, 9810. And when I have a uniform load, what's actually happening is it's not really a point load in the middle. It's really that it's getting less and less on each one of these. So what happens is I actually have a sloped line. And at this end, I know I have 9810 also. So what I know is I have a straight line from there to here, like this. Here it was the shear pointing up, and here it's the shear here. So that's our shear diagram. Now we need to do our moment diagram. Again, our moment is 0 at the supports, and because this is a diagonal like this, again, it's actually related to calculus, but it gives us a parabola for our moment. So I'm going to draw that in. But again, to find my max moment, all I need to do is find the area under the curve here. Well, this time it's a triangle, so if we remember, our formula for a triangle is just 1/2 base times height. So 1/2, the base here happens to be the 9 foot, and the height happens to be 9810. And we get and I'm going to put that on my diagram. And that's all there is to a uniform load. Thanks for watching.